Chapter 2 Geometric Sequences. After Chapter 1, we know about arithmetic sequence. Then now we have a look at another kind of sequence, geometric sequences. In Chinese, this one. A geometric sequence is a sequence having a common ratio between two successive terms. Okay, let's see these three sequences. 1, 2, 4, 8, 16. Do you know the properties, or do you know the relation between the terms? Yeah, you'll see that times 2, times 2, times 2, times 2, right? So this one times 2, for each term you can get the next one. How about the second sequence? 1, 1 over 2, 1 over 4, 1 over 8, 1 over 16, and etc. So you found that this one times 1 over 2 times 1 over 2, right? Then you can get the next term, so times 1 over 2. How about the third one? The third one. 11,000, 12,100, 13,310, 14,641. Any idea? Yeah, for each one you times 1.1, right? So times 1.1, and then you can get next term. So you'll see that there is a common pattern for the above sequences, of which the ratio between any two consecutive terms remains unchanged. Have a look. Have a look. So I take the second one over the first one. I take the third over the second one. I take the fourth one over the third one. You found that it keeps this constant value, 2. That means each term times 2, you get the next one. How about the second sequence? Yeah, take the second term over the first one. Take the third term over the second one. Take the fourth term over the third one. And you found that this one is 1 over 2. And the next one, 1.1. Okay? Take the later one over the previous one. Okay? For example here, the fourth term over the third term. You get this value. And they all have the same value. We say that this one, and this one all are the common ratios. Okay? The common ratio of the first sequence is 2. Common ratio of the second sequence is 1 over 2. Common ratio of the third sequence is 1.1. Right? Okay, now have a look. 2.1a and 2.1b. Understand more. 2.1a, 3, 6, 12, 24. What is the first term? Yeah, it's easy. 3, right? How about the common ratio? Common ratio here, 6 over 3. Check one more, 12 over 6. You found that this one is 2, right? Then do you know Tn? Tn here is the general term. Okay, general term. General. Okay? We'll write like this. A is the first term. common ratio, we say it as R, okay? 3 times common ratio and then n minus 1, like this, okay? 2.1b, have a one more. First term is 1 over 4, correct. How about the common ratio? Take the second one over the first one, and check one more, the third one over the second one. What can you find? Yeah, you found that this one is negative 1 over 3. So what is the general term Tn? First term times the common ratio, and then times to the power n minus 1. Do you know why we get this one? Have a look. For a general sequence, A is the first term and R is the common ratio, and you can get that A, second term A times R, third term A times R squared, A times R cubed. For the fourth term, this one is the fourth one. This one is the third one. So this is the nth term. Okay? So A times R to the power n minus 1. For example, just now, 1, 2, 4, 8, 16, and etc. This one actually comes from 1, and then 1 times 2, 1 times 2 square, 1 times 2 cube, 1 times 2 to the power 4. Can you see? This one is the fifth term. And you found that the power is here. This one is the third term. And the power is here. So for this one, nth term is 1 times 2 to the power n minus 1. This is the nth term. Understand? So this one, Tn equals A to the power A times R to the power n minus 1, where R not equal to 0 and n is a positive integer. Understand? You can have a look at checkpoint 2.1 by yourself on page 5. Okay?